In the previous episode, we created tools to automate the creation of containers in our DevLab. And today we will design the DevLab's network and build a Debian-based router using Ansible. Our DevLab consists of a virtualization server which hosts tens of development environments, a router, some network devices like printers or NAS, and a few developer machines. Class C supports 254 devices, and it is more than enough for our use case. We will assume that our DevLab subnet is 192.168.100.0/24. This is an IPv4 subnet, and we will start setting up the network using the IPv4 stack because it is more widely available. IPv6 requires ISP support to be fully functional, and we might not have that everywhere. We will avoid it for now, but we will come back to it later in the series and update our setup to work on both stacks, IPv4 and IPv6. This is the virtual environment that would simulate my main lab, which is actually running in a VM in the actual main lab. As a VM, this is connected to a network that is connected to a physical board. So this board here is connected to MVMBR0 on the main, actual main Proxmox virtual environment. And we have here the VMBR100, which is designed to host our new network. This is a network internal to the main lab, to the virtual main lab. And on this network, we have two devices. We have this device, which is a Proxmox virtual environment, another virtual environment nested inside this one, and this one has one connection only to VMBR100, which is not connected to anything right now. We also have this device, which is a Debian desktop, connected also to VMBR100. And if we look at this desktop, on the left side, on the right side, sorry, I'm logged into the Proxmox virtual environment to other server, and this is a Linux PVE. And since both the devices are on the same network, they can talk to each other. But if I ping anything in the outside from both devices, I cannot reach any the outside world. Our goal in this episode is to create a container in this Proxmox virtual environment that connects both those ports and would allow anything on VMBR100 to reach the outside world. We already have automations to create a Debian container in Proxmox. So let's start by using that for a Debian router. This is a playbook that should create the router. I added here custom variables for the router, and here we call the same role that we created yesterday. And if we look at the router variable, we see that I'm giving it VMID222, which is a required variable for the creation. The host name also is a required variable for the creation, and I'm giving it two networks. The network one, I'm calling it ETH0, and it's connected to VMBR0, which is on the physical network, and it gets its IP using DHCP from my main network router, which is a physical router board running router OS. Now, the second one is ETH100. I'm calling it ETH100, and it's based on the bridge VMBR100. I'm giving it a static IP because this will be the router. So if I run this playbook, we are creating the container. The container is starting and we are done. And you see in the network here, we have VMBR0 and VMBR100. And let's now connect these two and establish routing. Here is the Ansible role that I created to configure a Linux router. We first configure IPv4 routing in the kernel. And for that, we use the POSIX collection, and we call the systemctl cctl model in the POSIX collection multiple times with a dictionary of values. The documentation for these values is available in this link, and this is basically the kernel, Linux kernel documentation. The first task we do is we enable IPv4 routing. Then we enable SYN flood protection to protect against basic attacks, and we enable source validation for incoming packets. Then what we do is we copy the NF tables configuration. So I'm modifying those configurations with this file. The file is here, and basically this is the original configuration of NF tables. All these, they come from by install, they are installed. I'm adding the NAT network address translation table, and this NAT table contains two chains. First, I'm enabling pre-routing, and I'm enabling post routing, and in post routing I am telling NF tables, I'm telling the kernel that anything that has the input interface ETH100 and the output interface ETH0, you have to masquerade it. Masquerade it means tell the internet or change the packet so that it appears anything that comes from this interface goes to the internet as if it is coming from this interface, which is part of the internet. It has access to the internet through my main router. After that, we restart NF tables. For this to work, there are two conditions. The first condition is that now we are connecting not to localhost, we are connecting to a different host from the Debian Ansible controller. So we need to define this host in our inventory file. And since we are connecting to a different host, not to localhost, we need to configure SSH connection to ignore host key changes, because SSH by default does host key changes. And since I am recreating my hosts all the time, I don't want to enable host key changes. The second very important thing that we need to do is to enable the Debian controller to connect to to other hosts using SSH. And for that, we need to generate a private key and a public key for the Debian controller, the Ansible controller. This is the command, and enter, and we get host keys. The host keys are here. This one is the private key. It should be treated as a secret. And we need to use the same private key if we redeploy this Ansible controller. So we need to copy the private key again to the Ansible controller. That's why I treat it as a secret, and I copy the private key into my vaults. So the private key is part of my vault. And I copy the public key into my PVE variables. So now I have 3 public keys when I create a new container using this role. The first one belongs to my original Ansible controller. This one belongs to my desktop that I am using now. And the third one is this one that we created now, and we will use it for this Ansible controller. So since we have configured, we have the role now, and we have configured the inventory file, we can add this to the playbook. The way I do it is I have a new task in my playbook, configure the router. I run this on the host's Debian router that we configured in the inventory file. Then we call the role. Now let's try running this playbook and see what happens. So we will recreate the container, the router container. It was recreated, and we are configuring it, and the configuration is done. So now this should be a working router because I configured the gateway on these 2 hosts to use the same router. So let's check that. If I do the ping here and here, it takes some time, but the ping works. It took some time because because of the way ARP works. Now that we have routing enabled in our network, we need to discuss network segmentation. So we know that we know our subnet now, and we are using an external resolver for the time being. Later on, we have to install a dedicated DNS server so that we can have our own domains in our network, and later on also we need to connect them to SSL, and we'll have our own certificate authority. But that will come later in the series. We also know that we have a few static hosts. For example, the router takes IP1. This is configured as static. And as for now, since we do not have DHCP, I have configured the dev machine on port 9 on IP90 and the BVE on IP99. We also have a few ranges for DHCP configuration later. For example, we have from range 2 to 19. Those are static hosts for things like printers, NAS, backup server, or any host that we need to put on our DevLab network. We reserve IPs 20 to 50 to DHCP as a DHCP pool because these will give, for example, to wireless devices that want to connect, to any guest that wants to connect to our server. If we do not have a static IP for a certain host, for example, it can take an IP from the DHCP pool until we specify the IP for it later. We also reserve the range between 51 to 99 to developer hosts, and DevLab BVE will be one of them. The dev machine also is one of them. IPs from 100 to 254 are DHCP controlled and reserved for the BVE guests. Since the first the first ID on Proxmox is by default 100, we can assume that we can configure these from with IPs from 100 to 254 if we give these hosts the IP that matches the ID in Proxmox. We can do that with some automation on the DHCP level, and we can start by designing a custom scheme for MAC addresses in our main BVE and in the DevLab BVE. So in the main BVE, we start each MAC address with 02000000. There is a reason for choosing this 2 here, because this sets a bit in the MAC address that tells the network that this MAC address is locally administered. And the network identifies that and treats it according to an IEEE standard. So the format of the MAC address would be with this suffix on the main BVE and the corresponding suffix starting with 12 on the DevLab BVE. For example, for VMID 123, we give it the suffix 01:23, which corresponds with its VMID in both the DevLab and the BVE. And if we configure our DHCP to recognize this MAC address and give it a predictable IP like 123 here, which corresponds to the same ID in the BVE, we will come up with a scheme that gives each host we create on BVE a predictable IP address, not a random IP address from the pool. Here is a small Ansible script to calculate it. Basically, we have the prefix and we divide the VMID by 100. We take the result and we format it on 2 digits, and then we take the result of the remainder of the division by 100 and we format it on 2 digits so that we can get a leading 0 if required. This works with us for VMIDs ranging until 10,000, everything with 4 digits. It will work well, which is more than enough for our Class C network that we designed. And we said that we want only a maximum of 154 IPs reserved for Proxmox hosts. DHCP is traditionally one of the roles of the router. So when you buy a router, you expect to have a DHCP server built in inside it. But that is not the case. That's not obligatory. It's not what you have to do. You could put the DHCP server on a different machine. You could put multiple DHCP servers in your network. It's up to you how you design it. Which begs the question where to put our DHCP server. But better on, let's discuss where to put our router. So in our design, what we did today, we had a router connected to in one port to the outside world, to VMBR 0 on the main BVE, is connected also to VMBR 100, which is the same bridge that VMBR 0 in the Proxmox, the BVE is connected to. So we have the BVE in here and we have the router here. And in this case, any VM inside the BVE that is connected to VMBR 0 in the dev lab would connect via the router to the outside world. We could do that in a different way. We could put the entire router inside the dev lab. And to do that, we need to bring the two interfaces into the dev lab. So we have VMBR 0 connected to the outside world, to the main BVE, and we have VMBR 100. And in this case, we could have networks, we could have machines and hosts connected only to VMBR 100 or exposed to the outside world where they get an IP from both networks. Now, there are advantages and disadvantages for both designs. In my opinion, I prefer to put my dev lab's router outside the dev lab so that if I break anything or anything that breaks in the dev lab does not affect anything on my external network. Now, sometimes you might want to expose something inside the dev lab to the outside world. You can do that here by changing firewall rules. These are two possible designs and it's up to you. The DHCP server does not have to be on the router. You could put the DHCP server here, for example, inside the dev lab, or you could put it on the router, or you could put it on an external container that is connected to the same VMBR 0. Today, we will not make a decision about that because we are not going to set up the DHCP on this router. We will configure a full router using the cloud router from Microtech in the next episode. And that would be a complete router with DHCP with full automation for all the network services that we need in our network. Later on, we will come back to the Debian router and we will add enterprise grade services to it. For example, we will add here a DHCP server and we will add the bind9 DNS server to it, and we will run all these services along with our Debian router later on in this series. So please subscribe so that you do not miss the next episode for configuring the Microtech cloud router, or the episode that will come later for configuring the enterprise grade services on our Debian router.